Okay, the topic we really wanted to talk about today was simply this, okay? So it's compound interest and exponential functions. Now we wanted to establish what compound interest was, because this is a concept that, in my experience, a lot of people aren't familiar with. So let's just say that you have $1,000 and that $1,000 equals 100%, earns 100% interest. Okay, now I didn't say that it earns 100% interest in a day. I didn't say it earns 100% interest in a year. 100% interest in 10 years might be a reasonable, but fairly generous, at today's rates, would be a pretty good return, 100% in 10 years. But let's just leave the period unspecified. If somebody comes to you and say, give me $1,000 and I'll give you $2,000 tomorrow, that means you have 100% interest between today and tomorrow. Of course, you're probably never going to see the person again, so that would be a risky investment. But if it worked out, you know, you do okay. I wouldn't advise it. It's probably illegal. Okay, so $100 earns 100% interest over some period. So it earns $1,000 because 100% of $1,000 is $1,000. So you then have $2,000, right? Okay, pretty easy. And that's pretty good, whatever the period is. Well, if it's 100 years, it's probably not a very good deal. But let's fill in a couple of words here that got smudged. Okay. What now if you say, tell you what, you give me 50%, you know, you're going to give me $2,000 tomorrow, I want a better deal. What I want you to do is split that 100% into two parts. And what I want you to do is give me 50% tonight. Okay? Then I will have, if I trust her to give me my $1,000 back plus my interest, I will have $1,500. Okay? Then apply the other 50% to that $1,500. Now it's going to give me a little more money. It's going to give me about $225 extra dollars. You want to make the deal? Okay, that's the deal. And maybe you take that and maybe you don't. And maybe I'm just trying to run you off. Because then I said, wait, whoa. No. I want to take 10% 2 hours from now, and 10% 2 hours from that, and 10% and so forth, every time applying the 10% to what I have after earning that last 10%. And pretty soon I'm going to get you all confused, and you're either going to shoot me or go away. Okay. Well, so the deal is, you earn 50%, then you earn 50% of what you have after earning the first 50%. How much are you going to have? Well, people didn't have much trouble with this. They said, okay, well, after we earned 50%, we got $1,500, right? $1,000 that you originally had, that's your principal plus your interest. So that's your $1,000 has grown to $1,500, and now you're going to get your next 50% on that $1,500. Based on the $1,500, and 50% of $1,500 is $750. So now you have $1,500 and $750. That adds up to $2,250, which is why I say you get $250 more than with this deal. Okay, so that's better than the previous $2,000. Well, that's the idea of compound interest. And then we could say, well, okay, I want to take 10% and I want to do this 10 times. So I've got $1,000. I'm going to take 10% of $1,000 first, and that's going to be $1,100. Then I'm going to take 10% of that, which is $110. So I'll have $1,210. And then I'm going to take 10% of that, which is $121. Give me, okay. So, and I do that 10 times because to get my 100%, I've got to do 10% 10 times. Well, that comes out better than the $2,250. Okay? However, no matter how many times you do it, even if you do it once a second, it turns out that you have a limited amount of money. No matter how many times you break up this interest in this manner, you can't exceed you can never get more than $2,719. Might seem like you just keep dividing up the interest more and more times, you keep getting more and more money. That's true, but the extra amount of money that you get becomes, for each extra compounding, becomes very small. And we'll study that. We'll see how that works. Now, the other thing I say is, if you say, okay, I just want to get the interest continuously, okay, every microsecond, no, every billionth of a second, no, just continuously. Well, you can define a continuous interest based on this model. As you divide more and more times, your interest will approach what you would get from a function like $1,000 multiplied by 2 to the kt, or t is like your time or something, okay? And we'll make this specific. That's the interpretation we would normally have. And you recognize this as an exponential function, right? 2 to the kt is an exponential function. So this is an exponential function. So that this compound interest idea leads to an exponential function, and we're familiar with at least the 2 to the x function as an example of an exponential function. And we're going to then move into solving exponential equations using logarithms, which are inverse functions of exponentials, and we pretty much have a good basis for being able to do that.